All right, guys, so welcome back to lesson number 22, optimization for BC Calculus. And this is the last example that is, I consider, a classic optimization question that's usually given in BC Calculus. There's a multitude of other questions that you guys can be doing, but the four that I've done here are really just kind of the quintessential problems that you're going to see on the exams if it's optimization. So we're going to say that we have a semicircle of radius r, and it's going to ask us to find the area of the largest rectangle that can be inscribed, good old geometry word, in the semicircle of radius r. So inscribed basically means that the corners have to be touching the circle, and it's got to be inside of it. All right, so I'm looking for this right here. And so I'm looking for the area of the largest rectangle. Well, that's awesome. That's awesome because area is simply going to be equal to length times width. The length times the width. So I need to find the length and the width of this thing, and then I just need to find the derivative set equals 0, and we're going to call it a day, right? That's how you do it. So we're going to go ahead, just for the purposes of this problem, we're going to make the distance from the origin to right here, we're going to call this our x. Okay, so that means that this distance is x. That means that this distance is also x, right? Because this is a semicircle at the origin, so this side is equal to that side right here. So we can go ahead and say that the length of our problem is going to be equal to, or whatever you want to call this. I'm going to call it the length. It's lying down on the side, so it's going to be called 2x. Okay, so that's going to be what we're going to do here. Now, how to find this guy right here, this right here. Now, we just can't call this y. I mean, we can absolutely call this y if we want to, but remember, again, our optimization rule is we have to figure out a function that's in terms of one variable. So we can't just take 2x and times y. So this is going to be the point xy, which is right here. So if we're looking at a semicircle, then we have to look at the fact that y, well, actually x squared plus y squared is equal to r squared. So this is a combination. This is what we can use to figure out this circle. And so y squared is going to be equal to r squared minus x squared, and y is going to be equal to the square root of r squared minus x squared. So I could, if I wanted to, make my width equal to the square root of r squared minus x squared. And so finally, I can now say that the area of this rectangle, and so that's what y is equal to, right? This is going to be equal to the square root of r squared minus x squared. So now I've got my area is going to be equal to 2x times the square root of r squared minus x squared. Now some people may be thinking, wait a minute, you said that you could only get your equation in terms of one variable. Well, yes, ladies and gentlemen, this is an equation with one variable because our radius of this circle is a constant. It is a constant. So this is actually a number. So this is actually okay. We're fine with that. So this is our equation, and now we have to take the derivative of this, which means we have to use the product rule. Right, we have to use the product rule. So we're going to do 2x, and then we're going to multiply by the derivative of this, which is going to be 1/2. We're going to leave everything inside of the parentheses alone. It's supposed to be a 2, to the negative 1/2 power, and then we're going to multiply by the derivative of what's inside this parentheses. Well, the radius is just a number, so that derivative is going to be 0. So it's going to be minus 2x. Okay, so that whole crazy thing right there. And then we're going to do plus the second, and then times the derivative of the first. Now, yes, there's a crazy task that we have to do here with this. We have to set this equal to 0. We do have to set this equal to 0. So if I write this out again, more simplified than what you're going to see here, but we'll do it. We're going to get 2 times r squared minus 2x. So I went ahead and wrote this part first because this is a negative, so that's where this is written first, minus 2x squared all over the square root of r squared minus x squared. And the reason why they're, just the only thing got simplified here is that this 2 canceled with that 2. It doesn't really matter what it is. All right, so now we get that, and then there comes the fun algebra part of this. So we can have 2r squared minus x squared is equal to 2x squared over the square root of r squared minus x squared. Again, ladies and gentlemen, we can cancel the 2's out. And so when we cross multiply, because this actually turns out to be pretty awesome of a problem, because when we cross multiply, we're going to get r squared minus x squared, the square root of that, times itself. So we're going to get r squared minus x squared is equal to simply x squared. So we're going to get 2x squared is equal to r squared. So x, our distance x, remember we're trying to find the area of this thing, So we got to figure out, first of all, what x is. Well, x is going to be equal to r over the square root of 2. Okay, so that's going to be what the x term is. So ladies and gentlemen, the question is actually asking us now what is the area, right? And I went ahead and erase that because it's got a little crazy. So the area of the largest rectangle that can be inscribed in the semicircle. So we have to go back to what I wrote in red here. And so we have to find the area of this. So we're going to have 2. And then we're going to go ahead and do that x is going to be r over the square root of 2. And since I already wrote this up here, I know this is equal to y, but I just want to say that I can just go ahead and replace this as the square root of, and so r squared minus, and then so this is going to be x squared. Well, I'm going to go ahead and just square x, right? So it's going to be r squared all over the square root of 2. Sorry, r squared over 2, because we're squaring the top and the bottom, right? Squaring the top and the bottom. And so let's just kind of simplify this the best way we can. So we have a 2r over the square root of 2. And then this is going to end up being the square root of 2r squared minus r squared all over 2. And then we can simplify this a little bit more. And so we're going to get the square root of this is just going to be r squared in the top. And this is going to be the square root of 2 on the bottom. Right, so I just went ahead and I just simplified this by subtracting this, and then I did the square root of the top over the square root of the bottom. And so I'm going to get 2r times r all over 2 times 2. Sorry, square root of 2 times square root of 2, which is just going to actually be 2. So let's actually make that just 2. And that ends up just being r squared. So what about that? Look at that. So the area of the largest rectangle that will be inscribed into a semicircle of radius r is going to be when radius is going to be squared. Okay? So there you go. That's how you solve that problem. A little crazy, but we got there in the end. Most of optimization, you guys can see, the calculus part is not really the challenging part. It's really all this crazy algebra stuff that we have. But that's that question. So I hope that makes sense, and I will see you guys back in our next video.